it's important that we recognize that this is happening on more than just Kubernetes. That's why I think it's a movement that's happening.
Absolutely, yeah. Diverse ecosystems are healthy ecosystems. Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another episode of The Week in Green Software, where we bring you the latest news and updates from the world of sustainable software and software development. I'm your host, Chris Adams. And in this episode, we're going to be covering 3 stories about green software and the acronyms PaaS, SaaS, and IaaS. We'll also be discussing some exciting upcoming events in the world of green software and talking about moats and open AI. Before we dive in, though, please let me introduce myself, my guest for this episode of This Week in Green Software. Today we have Max Schulze. Hi, Max.
Hey, Chris.
Okay, Max, although we've known each other since about 2019, when we first went to some green cloud procurement events back in Brussels many years ago, you may not be familiar. Some other folks might not know too much about you. So if you introduce yourself, then we'll jump into some of the stories.
Thank you, Chris. And thank you for having me as your guest today. It's always fun to chat with you and debate with you. I'm Max. I'm the director and founder of the SDIA, Sustainable Digital Infrastructure Alliance. That's why we never say that. We always say SDIA because it's unpronounceable. Very excited to be here. I also talk about digital infrastructure all day. I write about it. I think about it. I talk about it. And recently I've been very involved in driving data centers to be more sustainable and more transparent through like the European Energy Efficiency Directive, but also the Code of Conduct for data centers.
And this is something you'd be doing in not just German, but also in English. Is that correct?
Yeah, I'm one of the very few Germans that can also speak very fluent English. So it's not a problem for me.
Okay. All right, Max. Okay, so we've spoken about the format here. And for folks who are new to this, basically what we're going to do is look at a few stories that kind of came up across our feeds and came up on our radar this week. We'll share a little bit of reckons and share some extra context that you might not be too aware of. And then we'll look at some coming events. So Max, the first story we have here, before we actually go too far, we've used these phrases PaaS, SaaS, and IaaS. Let's just briefly define these because these might come in handy and we might refer to these a little bit later. So Max, let's start actually, because IaaS is at the very bottom. Let's start there, then work your way upwards actually, all right?
So IaaS for me is the commodity. It's compute, storage, and network capacity. Essentially is what AWS started with, EC2, VPC, and S3. Those were like the 3 primitives that you can build almost any software from and abstract it in a way that you don't see the server, you don't see the data center. So it's really like digital resources as commodities in the highest form of abstraction.
And IaaS, for most people, stands for infrastructure as a service, right? So you pay for things on a kind of monthly or hourly basis, almost like metered electricity. Yeah?
Yeah.
Okay, cool. All right then. So that's IaaS or IaaS. PaaS, the next one up, that's platform as a service, which as I understand it, you might not want to be working with all these low-level things yourself. So there are companies that provide higher order functions on top of this. So for example, you might choose to purchase cloud storage or some computing power from a hyperscaler or maybe a French company, say Scaleway or something like that. But you might also pay for someone to just give you a place to put a Docker container or a piece of run a program, and they take care of keeping it fast and secure so that you can just focus on writing some code. So that's platform as a service. Do you want to have a go at describing what SaaS or software as a service might be then, Max?
Yeah. So to me, it's the most ironic one because PaaS, like a database as a service, is also software as a service, but it's tools that developers use to build more software. So it's funny. And SaaS is when you then glue a lot of different kind of open source components together into a product. For example, this product that we're using to record the podcast is also a software as a service product. The most well-known right now is probably Office 365. Or like Microsoft Teams or now SaaS-based products, so usually subscription-based, usually web-based, but can also be desktop applications. But it's more about the fact that you don't have to maintain, run, or install any software. It just available to you at any given time as a service.
Okay, so we've defined these somewhat confusing terms. And Max, is almost like a taxonomy that people actually need to be armed with for them to understand any of this stuff. And it might be worth just briefly touching on that before we dive into one of the stories. Because I know this is some work that you've done when you speak to policymakers about them struggling a bit to try to work out where one layer ends and another one begins, and where you need to purchase these and how you actually purchase these.
Yeah, I think in tech or IT, we often lose simplicity to understand things or to make things understandable because we want to be so specific. We want to be 100% accurate. And a lot of people get lost in that process when they hear a hybrid cloud setup or on-prem versus public versus, something else, or a VPS machine or a dedicated machine. And you hear these things, it's like, what is this? And I think it's what I've really come to realize is that you have all these words, and think about it, public cloud 5 years ago didn't exist as a term. And now we're using it every day and every developer knows what it means. But outside of our bubble, very few people actually understand all these different technologies. And ultimately it's software, hardware, some form of infrastructure, networks, data centers, and energy. And that's it. This is the whole thing. But we have so many words to describe different configurations of those that I think it's really important that we have some kind of taxonomy. You also know that we wrote a paper on this some time ago to propose something. But I think we need very simplified explanation models so that we don't lose policymakers with our complexity.
All right, thanks for that, Max. So now that we've got a little bit of kind of background for what some of these terms mean, should we look at the first of these stories here? So this is one in Forbes from the CNCF, which is the Cloud Native Computing Foundation. They're talking about software projects and eco-sustainable computing systems. We've touched on some of this, the idea of kind of Kubernetes or low Kubernetes, and the idea that there are existing products and projects that could be adapted to basically tread somewhat more lightly on the planet, as it were. And this is the first time I've actually seen people in the CNCF really talking publicly about this and really talking a lot about their special interest groups, where they are essentially trying to get gaggles of nerds to talk about some of this stuff. And there's a few particular projects of interest that have been catching people's eyes of late. One of these is Kepler from Red Hat, which stands for Kubernetes Efficient Power Level Exporter, right? And that's been one tool which has been used to essentially expose some of the energy numbers when you run little clusters of compute so that you can start to quantify and understand the environmental impact from some of these tools. Max, I know that you folks did some work with a similar project or related projects around this, and it sounds like it will be quite simple, but I think you can share a few war stories about some of this stuff and where some of the difficulties might actually be when you're working with this.
So I think, first of all, it's great that the CNCF is actually talking about this. They've had this sustainability working group, I think, for almost a year now, and I'm glad that they're now going a bit more public with it. I think there's a lot of value in Kubernetes and what it can do in terms of distributing workloads across different physical locations and machines. I think the war story that you're alluding to is that I think we've seen a lot of technology solutions that enables load shifting, which is one of the holy grails. Like, I can move it where the energy is greener, I can move it where there's underutilization and things like this. The problem is that the infrastructure, so it doesn't matter if it's a virtual machine or the data center, doesn't actually expose these metrics that you would need to make those decisions, right? So we see a lot of workarounds where you're trying to guess which data center you're in, and then you're getting the emission factor of the whole grid around it, which doesn't really exist. And there's so much data missing that I think the problem to solve is not necessarily at the highest level, but rather in the levels below, making these APIs available, making these metrics available to enable load shifting, not to solve load shifting.
Okay, thanks, Max. This is also something we might touch on a little bit later when we talk about some of the events that we have upcoming here. I think you also did a bit of work with a project called ECO-Qube, when there was some discussion about actually exposing some of the numbers from data centers. Because as I understand it, one of the reasons people basically say we can't share these numbers is we don't have access to these numbers. But I understand that you ended up spending a bit of time looking into this specifically to see where the real pain points and what the possible solutions might be for people at the data center level to expose some of the numbers for the rest of us further down the food chain, as it were, so we can actually optimize for carbon.
Yeah, we did. We even released, it's going to go open source in, I think, a few months. It's running in 3 pilot data centers. It's basically a monitoring system like Prometheus and Grafana. But what is surprising that even though we in IT monitor a lot, right, the underlying infrastructure doesn't have a very sophisticated monitoring system. You can really imagine it like software from 20 years ago. It's not that you can just query, are the diesel generators on or not? Is the cooling system at 40% or 50% load? And so we wrote basically an experimental piece of software that collects all that data and makes it available as one unified API so that you talk to the infrastructure like you talk to some database system. And you just say, what's the energy mix right now? Is the diesel generator running? Is there a wind park running nearby? And you get all these signals and you can respond to those signals. And I fundamentally believe that when the signals are available, when the transparency is there, then software will adjust to the available parameters.
Okay, so we will share a link to this. What was the name of this particular project that we should be looking for, that we should be searching for if we do look into
the
this?
Environmental Data Agent, EDA. We renamed it, I think, to EDS, but EDS is already like European Data something, or it's European Space Agency, something related to that. So it's not the Environmental Data System, but the Environmental Data Agent, because it is really a physical box that sits in a data center that has 2 network cables connected, one from the IT side and one from the infrastructure side. And it also acts as a firewall because you don't want the data center physical infrastructure connected to the internet either. The security risk, of course.
When you talk about connecting that in that way, you're referring to the idea of maybe you don't want to have the cooling systems exposed so someone can switch them on or off, resulting in,
yes,
we already have heating problems as is right now. So making it...
You don't want it to be hacked. Let's put it like this. And the safest way for cybersecurity, for everybody listening who loves cybersecurity, the best way to protect a computer is to not connect it to the internet.
Okay. All right. Yeah. Okay. So that gives us some pointers there, and there's something to be talking about. Some of the CNCF projects that people might be interested in. So we spoke to Kepler, and we'll be touching on a proposal by Adrian Cockcroft, a former VP of Sustainability at Amazon, who's been talking about some of the actual proposed metrics that you could actually use. And he'll be explaining where some of the problems are when you do try to actually work out these numbers from existing providers. So that's one thing we could talk about maybe in a future episode. We might touch on it a little bit later on today.
Actually,
yeah.
What about you? Didn't you guys do something with Nomad?
Yeah, so my organization, the Green Web Foundation, we did a bit of work with Nomad because we saw a bunch of people using Kubernetes as a way to orchestrate all kinds of computers to run software. And we have a kind of tradition at the Green Web Foundation where we look for the people who are not the dominant providers, because they're often doing some really interesting work. So we did some work with Firefox, as an example, to put a carbon calculation library into that particular library as well, into that. But last year, we did a bit of work with the folks at HashiCorp, because we use Nomad ourselves to run our kind of internal infrastructure. And there's now a separate fork of Nomad, which does have this kind of carbon-aware computing inside it right now. So this is one thing that we did a bit messing around with. And also, the other reason is that I'm quite a big fan of a service called fly.io, which is one of these PaaS. It's a kind of way to manage software without having to actually be maintaining all your kind of Amazon accounts yourself, for example. And I think the idea of like green fly sounded kind of cute. So we were just doing some work. We're there to use that, basically. So we did some work on this, I think, last year with an organization called Ripe. They're the people who allocate IP addresses to the world, basically. So we did some work there. But yeah, that's the exposure that we have so far. Since in the last 6 months, what we've seen is Microsoft basically donate their own scheduler and a bunch of their own open source work specifically for demonstrating how they do carbon-aware computing. So there's a bunch of things around here, but that is probably the thing to look at if you're using Kubernetes. But if you are looking at Nomad, then I'm very happy to talk about this. And I'll share a link to a blog post where we explained how we would go about doing this and where we're moving to next, because it's got a lot easier.
I think it's important that we recognize that this is happening on more than just Kubernetes. That's why I think it's a movement that's happening.
Absolutely, yeah. Diverse ecosystems are healthy ecosystems, as we say where I work. Okay, next story. Let's talk about moats. So this is a story which is partly blogged by developer, Django co-founding nerd, I suppose, and now AI specialist or AI researcher, Simon Willison. He linked to this leaked paper from Google, which says, we have no moat and neither does OpenAI. This is basically a story which in many ways kind of goes against this kind of narrative that we've seen over the last year or two, where lots and lots of the advances in kind of machine learning and AI have been associated with ever larger amounts of compute. And while we did do a bit of research and point to some papers a few weeks ago where there is less of a link between absolute brute computing power and the actual kind of accuracy of models, there's now a really interesting paper talking by a kind of nameless person inside Google, basically saying since a bunch of open models have been released, the kind of gap between £1 million models and literally $100 models worth of training is really narrowing right now. And the quote that I think is probably good for setting the scene is this one. So this was talking about comparing models like, say, GPT-3 or Google's Bard, for example, with some of the more recent ones based around, I forget this, Llama, LMA, and Llama and Alpaca. I'll refer to these later on. While our models still hold a slight edge in terms of quality, the gap is closing astonishingly quickly. Open source models are faster, more customizable, more private, and pound for pound more capable. They are doing things with $100 and 13 billion parameters that we struggle with $10 million and 540 billion parameters. And they are doing this in weeks, not in months.
I think the biggest risk here is the rebound effect, because yes, it's now more efficient, so to say, to put AI models basically everywhere and everybody can have their own. And like I can have one for my Notion space, I can have one for my Basecamp, I can have one for my wiki, I can have one for my tickets. It just means that, same as with LEDs, we will get exponentially more AI models embedded into everything that probably in aggregate will use still much more infrastructure, much more energy, much more GPU power than ever before. I think it doesn't matter if you have 10 big ones or a billion small ones, the effect is probably almost the same, if not even worse with the small ones. So just looking at it from the environmental perspective, what do you think about it?
I think that automatically reducing the amount of compute needed for this, in my view, is a good idea. And if you just have a larger number of smaller players who are playing rather than just an oligopoly of 3 or 4, I think that means that when it comes to actually regulating and being able to have civil society involved, I think you get more people able to talk about this. And you don't just get to have innovations coming from a very small group of people. So I think that you end up with something which would be more representative of society and therefore probably coming up with uses and ideas which are probably not quite so full of some of the kind of gaps and some of the kind of blind spots that we've seen previously. So I think this, by having a larger number of people doing this, I think is a good idea. I think that makes it more likely that you have 1 or 2 people who are pushing for, say, the idea of these models being, as a part of you training, you basically say, I'm only going to run this on green energy, for example, or I'm going to disclose the information about how this has been run. And because you have more people who are actually able to do this, I think you're going to end up with greater transparency and people being much more explicit about both the provenance of the data and the actual cost in terms of environmental impact that's come into it in the first place. So I think this creates scope to compete on transparency and compete on the fact the data can be trusted and has actually been created in a more equitable fashion. So I think that's good. And there's another really key idea that I saw here was basically people saying a lot of these new open source projects, they're achieving wins not by having loads of data, by having much, much better curated data. And I think this is actually a much more promising direction to be going in than what we've been seeing so far, where you just throw ever larger amounts of compute. Because if you're, say, a Google or a Microsoft, you've made so much money that you don't know what else to do than spend $70 billion on buying your own company's stock, right? That makes you think that it'd be nice if there's just more people who are able to use this rather than a vanishing number of people involved here. I think that's actually useful from a governance and an environmental point of view, basically.
So also from a society perspective, you basically say, well, we had this property theft problem, right? Then also larger data sets, open source data sets address that. I agree with you. I do think, just for completeness, I want to say that we do still need rules for bias and lots of other problems. I think from a societal perspective, so the third component of sustainability, we do need still rules. I think we need rules, some basic ground rules and principles for what's okay to do with AI and also what problems are okay to solve with AI. There was a great article by The Economist on a war game that they play with nuclear weapons. And basically the end is that every minister and government person that plays that game says, I want to automate the decision of when to deploy retaliation strikes. And like everybody can tell, and also my neck hair went up, and I was like, no, you don't want to give that decision-making power to a machine. That's the whole point. And I think we need those kind of principles and rules of what you can do with AI and whatnot.
Okay. This is actually one thing that gets touched on a little bit later, is this whole explosion of much, much clearer data sets where you actually have a good idea of what the provenance is and how that's been created. Because this has been one of the problems that we've touched on in previous episodes when you are playing around with LLM models. If you look on Twitter, you will see lots and lots of people telling you about how your job will be destroyed if you do not learn to use OpenAI. But there's also a flip side to this about, or some of the labor rights associated with this and whose labor is actually going into these models and being obscured that we touched on. Okay, so this is the last story that we have. This is Technology Pools Enterprise Green Ambitions. This is from CIODive.com. And this story is largely talking about some of the providers of infrastructure as a service and what some of the mechanisms you might actually have available to you to reduce the emissions associated in your supply chain. So this is aimed at telling CIOs, okay, there is this thing called Scope 3, which is like a kind of way of thinking about the emissions in your organization's supply chain. And it talks a little bit about which companies are doing better than others. And we've seen some new updates from actually Amazon, of all people. So for the last year, there was like kind of initial rush to get an early version of, say, Amazon's cloud computing sustainability dashboards out the door. And then no updates have happened for 12 months. And then we've seen some updates again. So it looks like folks are starting to pick up on this. But that is not the whole story. And I think, Max, you might have some reckons to share on this one here, actually.
Yeah, Chris. I'm going to be very diplomatic here. I admire that Microsoft is very transparent about their Scope 3 and their data reporting. You have to take it with a grain of salt, because if you go one layer deeper and you look at the available data from, let's say, how much emissions is in a data center building, how much is in a server, even HP and Dell's reports are, let's say, vague. So let's say if you look at it as like a chain of data that you need to collect, I think that it's starting, and it's good that the big ones are really saying we want to be more transparent, and then they realize, oh, we don't have the data from our suppliers. I think that's a good thing. I think that it's always tricky because even the GHG protocol is made mostly by corporations. They make their own reporting rules. So I think there's a lot of work still to be done to include all environmental effects. I do agree with the article also talks about third-party vendors and consultants. I think there's a lot of tools being built to help with this. Our formulas have been integrated in Dynatrace's monitoring tool. So in Dynatrace, you can actually now at least calculate the energy of your AWS systems, and you get very much larger numbers than AWS is reporting to you. So yeah, again, comes down to rules and standards. And I think in tech, this is the first time somebody's doing like a holistic inventory of all environmental impacts of digital technology. And we are lacking so much data at every corner. It's just not there. So a lot of these things are really brutal estimates right now.
This is true. We spoke about this change. We were surprised by some changes coming through, and I'm afraid this is a bit spotty and nerdy. This energy efficiency directive that was basically mooted recently, that is seen as a transparency win for a few people. Basically, to provide a lot more transparency at a data center level that you haven't seen previously. Max, I think you had some exposure to this, or you saw how some of the, what they say in German, how the sausage gets made, right? Maybe you could share a little bit on this one. Yeah.
Yeah. Yes, we were very involved in this process. It was very politically loaded. It's essentially about, so even the big cloud companies often rent data center capacity at co-location facilities, which are, you can think of it like WeWork for your servers, right? You get everything, power, cooling included in your rent, but you have to bring your own servers. And some of these companies are very intransparent about your energy consumption, the emissions of your energy consumption, the embodied emissions. And this law essentially forces them to both make it public and then also attribute it and give it to their customers. And that's quite the game changer, especially because the law, the first reporting interval, you pointed this out as well, is already in May 2024, which is very short notice and will drive a lot of data centers to now really quickly scramble together a reporting system. Right now, they mostly use spreadsheets. And that's why also what you mentioned earlier, our EDA project, of course, can help with this. That's why it's open source, so that every data center can deploy a monitoring tool and then release that data as quickly as possible. And I think that will also increase the accuracy of what the hyperscalers are reporting, but also what you as a developer have access to, I hope. It's, of course, all your DigitalOceans and AWSs have to still pass through that information, but the law really sets the stage to get the data in place to begin with.
I see. And there was one thing that surprised me when I read through this was this real focus on heat reuse, basically. Now, that's a key thing. It's starting to be warm again, at least in Western Europe compared to other parts of the world. But we do know essentially space heating or heating things up is one of the big sources of emissions for this. And I think, Max, you mentioned some of the idea, like one of the reasons some of the transparency stuff might have come through is because there was a almost disproportionate amount of interest in making sure that heat gets reused by various organizations. Is this something that you saw?
Yeah, absolutely. I think heat recovery has been something the SDIA has been talking about for 5 years as like, why on earth are we putting 100 megawatts into a system that produces 100 megawatts of heat and then not use it? Because you know your computer generates heat. Every electronic process generates that heat, and it's just silly to not use it. And because you mentioned it, this idea, for example, that in summer you can't use the heat is complete bollocks, because storing thermal energy, right, putting it in an underground tank to store the heat, you can store it for a whole year until winter. And hear this, to store energy 1 kilowatt in a lithium ion battery costs about $180 per kilowatt hour. Storing 1 kilowatt of thermal energy using any form of tank, $1 per kilowatt hour. So
okay,
not storing that heat, recovered or not, we have to use it. It is like literally we put all these green electrons, right, all this green energy into this data center, and then instead of reusing those green electrons, we just throw them away as heat. And it's the rarest commodity we have on this planet right now is green electricity. And we should use it as much as we can in as many times as we can. And yeah, I'm really glad that the directive suggests that, or basically forces the data centers to at least consider heat recovery and show proof that they have considered it.
Now, and this is something that I understand has been so outside of this world. I'm a bit of a kind of heat nerd because I know that Denmark is actually one of the countries which has a long history of storing heat for long periods of time, just like this. And I think I might have spoken out of turn about just when it's hot, you might not want to put the heat somewhere. But you're absolutely right. There's various parts of the world where they store things in significant bodies of thermal mass, like pools underwater and so on, so that you can pull the heat out. And as people end up using things like heat pumps and so on, you're able to move it around to other places to make better use of that, actually.
Yeah, spot on.
Okay, all right. We're a podcast about green software and not just heat. So I'm just going to look at some of the events as we run up now. So we have, I think, 2 or 3 events on the horizon that are coming up here. The first of these is this Rise of AI 23. This is happening in Berlin on the 9th and 10th of May. This is a hybrid one. And basically, the responsible AI crew starting to look at carbon neutrality and trying to understand the actual leverage points on a project to work out where you can make meaningful savings here. This is a free thing to join to see some of the talks. And there's another event taking place later on in May that I think, Max, you might have something to say about here because it has your organization's name on it, actually.
Yeah. So we are hosting a hackathon with the German Environmental Agency to measure the environmental impact of software. This is really about measuring. And we build a test system where people can basically upload their code to a GitLab account. And we have a special CI/CD runner that people can use. And that runner is, so to say, energy aware and also carbon aware. And it measures everything. So what we're going to do, hopefully, is take some open source projects like Django or like some Node.js library and going to basically see what can we change in the code and then run all the tests again. So without reducing the functional scope, without removing any tests, how can we make it more energy efficient? How can we use less energy or use less server capacity, and also measure in between different versions of software. That was an idea that somebody brought to us that I thought was really exciting, to say, when you release a new version of a piece of software, can you basically do a diff of the energy use versus functionality growth, and basically say each new version should not use more energy than the version before, unless it adds like significant amount of functionality. Free to attend.
Like how cars. Oh, cool.
Yeah,
all right.
exactly.
So a bit like how cars keep getting bigger and bigger, and some of the things you might care about, say crash safety, but some other things like cup holders you may be less excited about, or there's maybe things the idea is to provide that level of transparency to make some of that more visible to people, yeah?
Yeah. What you can measure, you can change, right? And so I think if we make people aware that their software keeps growing in terms of environmental impact, then I think there's more incentive to reduce it.
I see. And this is part of the project, I think, of the German SoftAware, the project with the Federal Environment Agency, the Umweltbundesamt, who are doing this work.
Very good pronunciation, Chris. Trying
to get some practice in. All right. Actually, there's another story we didn't have time for, but I'm just going to share because it caught my eyes. Basically, the Sovereign Tech Fund is essentially a fund in Germany, and they've basically made a donation of 875,000 euros or $900,000 to the OpenJS Foundation. So the foundation that maintains like Node.js and various tools like that. This is the first time I've seen a government make a direct donation in this kind of fashion for quite a substantial amount for something like this, actually. This is like the focus on security rather than sustainable software, but it caught my eye because I was not aware of just how much, I guess, the German government is involved at the software level now.
Funny. I think it's interesting because that also means that soon the open source community will finally get political. Because once you take the money from the government, you also have to have a position.
This is very true, actually. And I wonder, this might be something we touch on in a future episode, actually. Okay, so we've got that happening on the 24th of May. That's the hackathon there that people will be going along to, or that you can go to. Final event that we have listed here is the LF Energy Summit taking place in June. So this is happening at Window in La Défense, Paris, France. And this actually has a few people from the Green Software Foundation presenting both the Green Software Principles and the Carbon Aware SDK, which is an open source software development toolkit for people who are building projects using the kind of Microsoft stack, using C# and so on, and trying to basically reduce the impact there. This is something that I think we also touched on, Max. You spoke about the idea of Linux appearing in various parts of the kind of energy sector now. And this, to my knowledge, is where you see a lot of people in the kind of open source world now looking at lots of proprietary SCADA infrastructure tools and say, maybe we can use some open tools to make it easier to maintain and manage this stuff. Because once we go down to the data center level, it can become a bit harder to get the numbers or basically work with open source software the way that you might see it at kind of infrastructure level, really closer to the metal.
Yeah, generally a bit worried because I think the energy system works, right? Our computers right now are running, the light is on, there's no problem to fix. What we need to do is to scale renewable energy as quickly as possible. And the technology for that, we have 14 megawatt wind turbines now, is really there. And a lot of the problems in renewable energy is about people. It's about permitting. It's about, I don't want a wind park in front of my house. I don't want a solar field next to my house. And I don't think the solution is digitalization right now. I think as the tech sector, as digital people, we need to look at our own stuff and not go bring our stuff to other industries right now so much. We need to make sure that we are not going to be the bigger problem at the end as the biggest energy consumer left or something like this. I'm always trying to put us back on track. Like tech can solve tech. We don't need to go solve energy system right now because energy system is already on track to decarbonize itself. And let's just let them run with that. If they need help, they will call and we do us.
Okay. All right. Okay, Max, I think that's wise words indeed. Max, thank you so much for coming on to this show and this conversation. I really enjoyed chatting with you and I hope we can do this again sometime soon.
Me too. It's always a pleasure to talk with you, Chris. And I always feel like we have to rush so much, but we could do a lot. We could do 4-hour podcast episodes.
Maybe in the future we'll do that. Okay. All right. That's all for this episode of The Week in Green Software. All the resources for this episode are in the show description below, and you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables, the kind of larger name for this podcast. I'd like to say thank you very much again, Max, for coming on. And folks, see you next week on the next episode. Bye for now. See you around, Max. Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.